All right, it is day 17 of distance learning, and today we're going to be graphing systems of equations. So there are multiple ways to solve a system of equations, but we're going to focus in on graphing because that is a skill that we have learned. So it's very important, if you have not yet done so, to go back and complete the assignments from days 9 through 16. So we've already graphed lines, we've converted equations from standard form to slope-intercept form, and you need all of those skills in order to be able to do the practice that I have posted today. So we're going to get started. We're going to go through 3 examples, so hopefully you've printed this out or have it on a separate sheet of paper. We're going to go through these 3 examples together, and then you're going to complete your practice that's also uploaded to the classroom. So we have 2 different equations for this system of equations, and we're going to use 2 different colors to help us see the difference when I'm going through the graph. So we're going to start out with the first equation, and the very first thing we need to do when we're going to graph linear equations is make sure that the equation is presented to us in slope-intercept form. And what that means is that our equation should be in the form y equals mx plus b. That means we should be able to figure out the slope and the y-intercept without doing any work. So we just want to be able to identify the slope and the y-intercept, and then we can create the graph. So in this pink equation, y equals -3/4 x plus 1. I know my m, or my slope, is -3/4 since that's next to x, and my y-intercept is 1 since that's the number without the variable next to it. So let's graph it. Here's our y-axis. The y-intercept is at 1, so I'm going to go up to +1. And then I'm going to follow my slope. -3/4 means that we are going down 3 units, since that's our rise, and over to the right 4 units, since that's our run. So we're going to count down 3, 1, 2, 3, and over to the right 4, 1, 2, 3, 4. I'm going to keep following that pattern, but I've run out of room. So I'm going to go back to my y-intercept and go in the opposite direction. Instead of going down 3, I'll go up 3, 1, 2, 3, and this time to the left 3, 1, 2, 3, 4, left 4. And if you notice, even though I went in the opposite direction, my points are still in a line. And that's what happens when you graph a linear function. So I'm going to play connect the dots with these 3 points as neat as I can. We would be using our rulers in the classroom. There we go. And we're going to put arrows on the ends of our lines because these lines actually go on forever. So our first graph is complete. Our second equation says y is equal to 1/2 x minus 4. Again, I know this is in slope-intercept form because I can tell my slope is equal to 1/2 since that's next to x, and my y-intercept is equal to -4. Let's graph it. On my y-axis, I'm going to put my y-intercept down at -4, and my slope is telling me to go up 1 unit and over to the right 2 units. So I'll go up 1 unit and over to the right 2 units. Again, I'm going to keep going. Up 1 unit, over to the right 2 units. Up 1, but then I can't fit it. I'm still going to go back to my y-intercept so that my line is nice and neat when I connect the dots, and go down 1 and over to the left 2, and I've run out of room. So as best I can, I'm going to play connect the dots. And I'm going to notice something happens with these 2 lines. My pink and my blue line meet right here. That is the solution to this system of equations. So since they meet at 1 point, there's 1 solution, and the coordinates of that point are, don't forget x comes first and then y. The x value is 4, the y value is -2. So the solution to this system of equations is 4, -2, right at that point. We're going to try another example together. This time we're going to graph these 2 equations. First, I'm going to check to see that they are written in slope-intercept form, and they are. My first line, I will graph in blue this time. My slope would be 5 over 4 since that's next to x. My y-intercept is negative 3 since that's right at the end of the equation with no variable right next to it. And I'm going to make that graph starting at negative 3 on the y-axis, and my slope is up 5 to the right 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And I've run out of room. And if I went in the opposite direction, I still don't have enough room. So we're going to connect our points as best we can. And we have our first line. We're going to graph our second equation. Now don't forget, whenever you have a variable that does not have a number right in front of it, that coefficient is 1. So the slope of my line in pink is 1 over 1. And the y-intercept is negative 2. So again, I'm going to start on my y-axis down here at negative 2. And I'm going to count my slope. Up 1, right 1. 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 Until I run out of room, and again, continue that in the opposite direction. Now here's where neatness matters. You're going to connect your points as best you can, and you're going to notice what happens. They get very close beforehand, but this is the point that I care about. So since these lines meet at one point, there's one solution, and the solution to this system of equations is at the point 4, since that's my x value, comma 2. Now this happens to be the same two numbers, since it's not always going to be a 4 and a 2, but that's showing you that getting your point right, negative 2 is very different than positive 2 on the y-axis, on the y-coordinate. It really matters. So we're going to do one more example together before you look at your practice. And we're going to notice that this one looks a little bit different. So I'm going to use my pink colored pencil to look at my first equation. It says y is equal to negative 1/4 x plus 2. Since that has the y isolated and the m and the b on the other side, and I'm able to figure out that the m, or the slope, is negative 1/4, and the b, or the y-intercept, is equal to 2, I can go ahead and graph that equation right away. My y-intercept is up at the point 0, 2. My slope is telling me to go down 1, right 4. Down 1, and to the right 4. 1, 2, 3, 4. Down 1, right 4. I ran out of room, so I have to go the opposite direction. Up 1, left 4. I'll play connect the dots. And I have my first equation. As soon as I go to graph my second equation, which I'm going to use blue for, I notice that I can't figure out what m is or b. And that's because this one's presented to us in standard form. When you have your x and your y variables presented to you on the same side of your equation, that's written in standard form. So, really important, like I mentioned before, if you haven't done so, you have to make sure you go back and complete the previous days, where you have to convert this equation to say y equals mx plus b. And the first step when I'm converting is to move my x variable from one side, the side with y, to the other. In this case, I have negative 5x. We're going to use inverse operations, so the opposite of negative 5 would be positive 5. And I know that these are going to cancel out to give me 0. Negative 5 plus 5 is 0. But that doesn't just disappear. Whatever I do to one side, I have to do to the other. And notice again, I didn't line it up with negative 16 since those are not like terms. Let's do the math. We're going to bring down 4y is equal to, this time we have negative 16 plus 5x. So it's starting to look like y equals mx plus b, but we still have this 4. If this is multiplication, the inverse operation would be division. But this is where it's important. You have to divide every single term in your equation by that coefficient to undo that 4. So we're going to divide every single term by 4. 4 divided by 4 is 1, which leaves us with a y. Negative 16 divided by 4 is negative 6. And then if you notice 5 divided by 4, that's going to give us a decimal, but we like looking at the slope as a fraction, rise over the run. We have one more step left to make this look like mx plus b, and that's really just to change this order. We usually have the mx first and the b second, so I'm going to switch that around. Y is equal to 5/4 x, since that's mx, plus b, but in this case it's a negative, so minus 4. Now that we have rearranged it, I can see that my m is 5/4, that's my slope, and my b is equal to negative 4. It's now ready to graph. So I'm going to plot my y-intercept on my coordinate plane at negative 4. And then I'm going to count my slope. My rise this time is 5. 1, 2, 3, 4, 5. And my run is 4. 1, 2, 3, 4. And that's the only point that I could fit on this coordinate plane. So when I play connect the dots, I notice the solution is at the coordinates 4, 1. Since my x value is 4, my y value is 1. So for today's practice, you're going to go through looking at identifying solutions. So some things are going to be graphed already for you, and you'll identify the point where those two lines intersect. And then the last two you're going to be graphing yourself. So take a look at previous videos if need be. One thing I want to point out, if your lines end up looking like this, that means they're parallel. Those lines are never going to intersect. And so what that means is that both of these lines won't have the same point in common. That means there's no solution to this system of equation. So that means no point can be plugged into both of those equations and come out true. So there's no solution. Another type of an answer is if you graph one line, that's our blue line, and you go to graph the second line and they end up right on top of each other, that means that every single point is in common. So that's when you have infinitely many. Every single point on the blue line is also on the pink line. So that's when you have infinitely many solutions. But most systems have one solution. So that's when the lines meet at one point, and you are then determining what the coordinates of that point is. So if you have any questions, please send me an email. Your classwork is also uploaded into today's Google Classroom assignment. Please let me know if you need any help.